Welcome back again. This is Mr. Thompson with another video from our calculus set. This time looking at a problem from problem set 1-3. We're going to look at problem number 5. As you can see, I'm starting to copy and paste them into the picture so you can better see what I am doing, especially since we have a graph involved. Now, section 1-3, if you watch the other video, talks about how to count the squares under a graph. It seems pretty simple to count the squares, especially in this situation. Now, the reason why it's helpful here is we're not actually given any kind of function. We're just told that a car is slowing down from velocity 60 feet per second. So here's 60 feet per second. After 5 seconds, we start slowing down, and it gets pretty slow. So this is not an actual function. This is just a real-life situation where the speed is changing. Now, parts of it are functions, but this little corner right there would mess us up trying to come up with an equation. So the idea is we want to estimate. So I can't stress that enough. This is an estimation. The distance it travels from time equals 5. So from here to time equals 25 here. So we want the area of the squares underneath the curve from 5 to 25. So, like I showed you before, all we have to do first of all is count. Let's count the entire squares first. 1, 2, 3, just 3 this time. Now, since we're dealing with such a small number of squares, I want to be a little more accurate on my estimations if I can, such as this one looks like it's between 1.8 and 1.9, so I'm going to go with 0.85. This one looks like it's between 0.1 and 0.2. I'm going to go with 0.15. Let's see, this one, that would be half. Looks like it's around 1.6, 1.7, so let's go with 0.65. This one looks like it's around 2 or 3. Let's go with 0.25. This one is almost complete, but not quite. Let's go with 0.95. And this one is a little over half, looks like around 0.6. I'm just going with 0.6. Add it all up. 5, 10, 15, 20, 25, carry the 2. 10, 11, 17, 19, 28, 34, carry the 3. 6.45 is what I get. Now, I want to see what is a square actually worth in value. On the side, it looks like we are counting up at a rate of 20, 40, 60, 20. Down on the bottom, let's see, 5, 10, 15, 20, 25. So we're counting at a rate of 20 going up, 5 going across, so one square is actually worth 100 feet. It is worth 100 feet. Now, I'm going to take my 6.45, multiply that by 100, which basically just moves the decimal over, but I'm still going to go through this. 5, 4, and 6, decimals 2 spots over, we get 645 feet the car has moved if it takes 20 seconds to stop. Now, it's not too hard to count the squares underneath, to go through and estimate a value. If we look in the back of the book, it has the estimation at about, and by the way, this symbol is an estimation, so about. The book says it's about 680, so 645, definitely good enough. Very small difference. If you had somewhere in the 800s or somewhere in the 400s, it's definitely not enough. Especially since we can tell there's 3 complete squares anyways, so that'd be 300. Anything lower than 300, definitely not enough. So try and stick in the range. Definitely check the back of the book if needed. However, in this case, it's not that big of a deal. The rest of the problems in this part are pretty similar. Now, some of them have you actually drawing the graph, some not. So just see what you can do. If you have other questions on different problems, just let me know.